Hi guys, we are now going to look at something called arcs and sectors. Before we go into it fully, want to make sure that we are all on the same page with a bit of background knowledge on a circle so that we aren't going round and round and round. Sorry, couldn't help myself. The circumference of a circle is the perimeter. It's the distance around the outside of the shape. So the black line is the perimeter. That's a distance. In order to carry out this topic successfully, we have to be aware of a few different things. First of all, this red line here, this straight line that goes from the centre of the circle to the perimeter, to the circumference, we call that a radius. So that red line, we call that a radius. The blue line that goes from one edge of the circle through the middle of the circle and then to the other side of the circle, we call that a diameter. So we'll get that written down as well. And that's essential knowledge that you will need in order to carry out this topic and quite a few other topics in National 5 successfully. The last thing that I want to have a wee look at just now is the formula for finding the circumference of a circle. It is circumference C equals pi, and then the D stands for diameter. If it's slipped out of your mind, let's also just include in here, we should all remember that pi is equal to 3.14. And that's the essential knowledge that we need in order to go forward with this topic. So let's look at what an arc is. An arc is a part of that circumference that we saw in the previous circle. In maths and in real life application, we sometimes need to find the length of the arc. What we tend to have, if you look at the circle itself, we have got this blue line and we have got this red line. These are both arcs. They are both part of the circumference. We've got specific names for them. For the smaller blue line, we would call that the minor arc. And for the larger red line, probably guessed it, we call that the major arc. The formula that we use to find the length of an arc is detailed here. It's called arc length equals angle over 360 multiplied by pi d. Let's break that down then. First of all, angle. Well, what angle are we talking about? If we were wanting to calculate the minor arc, so that blue line, then the angle that we would need for the minor arc would be this angle here, because that's the angle that goes with this portion of the arc. If we were looking to find what the major arc was, then we would need to calculate what this angle is, because that's the angle that corresponds to the major arc. That's that portion. Why do we use 360? Well, think about your knowledge of a circle. There are 360 degrees in total. So if we take the angle that corresponds to the arc and divide it by 360, we're getting a fraction of what that angle takes up. And we know that the arc itself is a fraction, it's a part of the circumference. The last part, pi d, think back, that is your circumference. So what we're really doing essentially is we're trying to find a fraction and multiply it by the circumference. And that allows us to find the arc length. In day-to-day life, we see arcs all the time. Think of a football park and think of the penalty box. On every penalty box, we have got an arc. We can't see the rest of the circle, but it would come down here. There is a way to calculate that arc length. What we would need is the distance from the penalty spot, because the penalty spot is the centre of the circle it would create. We need to know the length of the radius, because the radius will give us the diameter. So keep that in mind, because with some exam questions and some questions you might face, you might only be given part of a circle. You might not always be given a full circle. So keep that in mind. Okay, let's look at some examples then. Calculate the length of minor arc PQ. First thing I'm going to do is identify whereabouts the minor arc PQ is. We've either got this arc here, which goes around to that point, or we've got this arc here that travels around here. From the previous slide, we know the minor arc is the smaller of the two, so the distance that I want to calculate the length of is going to be from P round to Q here. That's where I want to calculate. First of all, what I'm going to do is take out some information from the diagram itself. I know that the radius is 11 centimetres, so from here to the edge of the circle is 11 centimetres. And I know that this angle that goes from the radius to the radius is 100 degrees. That is the angle that corresponds to my minor arc. And what I always tend to do is write myself a list. So I've got the information ready. So my radius is 11 centimetres. Because I've got my radius, I can calculate my diameter. Diameter is twice as big as the radius. My angle is 100 degrees. And for good measure, I'll include pi. Next thing I'm going to do is I'm always going to write down the formula. So always start with the formula. Do not start substituting first. So we've got arc length equals angle over 360 times pi d. Once I've got all that set up, I am then going to start substituting in my values. When we're doing these, you don't have to keep on writing arc length. You can just write arc equals 100 over 360 multiplied by 3.14. The pi and the d are stuck together. I know in maths that means multiply. So the last part is going to be multiplied by 22. At this point, I am going to go to my calculator and I'm going to type in exactly what I see. So 100 divided by 360 multiplied by 3.14 multiplied by 22, and you'll get a recurring decimal of 19.1888889. I'm going to round that to 2 decimal places, so it's going to be 19 19.19. It's a length, so make sure that you're putting in a unit of measurement. It's been given to us in centimetres, so I'm going to answer in centimetres. So the length of minor arc PQ is 19.19 centimetres. So let's look at the second one then. This time we are being asked to calculate the major arc PQ. So the major arc PQ. We know that this is the minor arc, so this is going to be our major arc. First problem that I'm going to identify with this is we don't have an angle for our major arc, but we're going to use a bit of our knowledge. We know that there are 360 degrees in a circle itself. We know that this portion here is 100 degrees. So in order to get the missing angle, do a quick calculation. We're going to do 360, take away 100. So we've got 260 degrees. That's that angle there. That's the major angle that we want. So again, I'm going to go to the side and I'm going to write out my list. So I've got the radius is 11 centimetres, which makes the diameter 22 centimetres. Pi is going to be 3.14. And my angle is 260 degrees this time. I'm then going to write out my formula. Don't need to write arc length, I'm just going to write arc equals angle over 360 multiplied by pi d. And then I'm going to start substituting things in. At that point, once I've physically wrote down what the formula is, remember we're never just going to start substituting from the start. I'm going to substitute in now. So my arc is equal to 260 over 360 multiplied by 3.14 multiplied by 22. When I put that into the calculator, I get 49.89111111. So I'm going to round that to 2 decimal places. So it's going to be 49.89 centimetres. And that is us calculated the major arc PQ. Okay, that's all from me just now. As always, if you have any questions, please let us know. This is Mr. Gillen signing off. Speak to you all soon.